All right, moving through with Earth history, we are now moving into geologic time. So we started out with the rock cycle, and then we moved into layers of the Earth and how the different plates on Earth move and how crust is created and destroyed. And now we are going to move into geologic time and how to look at different changing life forms and landforms of the past. And the first thing we're going to start off with is the principle of uniformitarianism. And if you break that big word down, you just look, the first part is uniform. And anything that's uniform means the same. And what this means is that the forces and processes that are happening today that we can look at and see today are the same as they always have been. They have been at work for a very long time, meaning the plates are still moving, they're still molten rock, there's convection currents, everything that's happening. And so because of that, we're able to date rocks and be able to sequence events to tell how old different land and life forms are. So there's two different kinds of dating that I'm going to talk about today. And the first one is relative dating. The second one is radiometric dating. Relative dating tells us the sequence or order in which events happened, but not how long ago they happened. So if I were to just stack some things on the table, some books, you would be able to tell which book was put down first by telling me which book was on the bottom. Well, rocks work the same exact way. So if you look at these colored bands, the oldest is number 1, which is the red one, because it's on the bottom. It was obviously put there first. The youngest is the one that's on the top, which is the yellow one, number 4. There's 3 principles that go with relative dating. There's the law of superposition. So again, position is, that word position is in there. So you know that we're talking about some kind of order. And what this means is that in an undisturbed sequence of sedimentary rocks, so sedimentary rocks are rocks like are in the Grand Canyon where you have lots of easy layers to see. It means that the bed on the bottom is the oldest and the bed on the top is the youngest. That's all that means. Here is an awesome diagram of superposition with sedimentary rocks. You see the oldest ones are on the very bottom and the youngest ones are on the very, very top, which means they were made last. The second principle of relative dating is the principle of original horizontality. Again, there's just a big word. The word horizontal is in there. So what that means is that when these layers are made, they are deposited or put down in a horizontal position. So one on top of the other horizontally, not vertically. And over time, as the plates move and push together, they might push up into mountains like you see in this diagram, or they might not. Just one. All right, we were ending on this one, and we had oldest on the bottom, youngest on top, and everything is horizontal. Okay, here we have the last principle is called principle of cross-cutting relationships. So when something cuts through another layer, that's all that means. And what that something is that cuts through is a fault, or when magma intrudes into another rock and crystallizes, we can assume that the fault or intrusion is younger, because you can't have something cut through something else that doesn't even exist. That something else had to have been. So here we go. We got all these layers, they're horizontal. We have the oldest on the bottom, and then we have on the top, it says older, because in this case it's not the youngest, and then we have this thing that cuts through all 4 layers. That thing that is cutting through all 4 layers is the youngest. And it's because all 4 of those layers had to have been there first before this thing came on top of it. And let's just say that this is lava, that some lava is escaping out and it's flowing over each of these 4 rock layers, and then it's going to harden, cool and harden on top of that. Also in relative dating, there's something called an unconformity. So an unconformity is a gap in the geologic record that occurs whenever you have rock that's eroded or exposing older rock then new rock forms on the much older rock. So what happens is you have a layer of rock that essentially disappears because of erosion, and then a new layer forms on top of it. That's called an unconformity, because you know that something was there, you just don't know what. All right, so what we just did was all called relative dating. Relative dating. Just, you can tell what order things happened, but not how old. Now we're going to get into absolute dating. With absolute dating, you can tell how old. Okay, the first kind is radiometric dating. And radiometric dating calculates the age of rocks and minerals based on certain radioactive isotopes. So isotopes are elements that have different numbers of neutrons. And so we'll get into some in just a minute. But basically, it's just an element on the periodic table, an atom on the periodic table that has a different number of neutrons. And that makes it radioactive. So radioactive dating uses half-lives of these isotopes, meaning how long it takes for half of the sample of this element to decay into another form. And it uses that because there's different isotopes in certain rock types. And so you can look at the amount of these elements that are in these different kinds of rocks, and you can test how much is left in each rock to see how old that actual rock is. Okay, so again, half-life is the time it takes for 50% or half of the nuclei in a radioactive sample to decay to a stable isotope. So radiometric dating is really cool because you can take that, you can multiply the number of half-lives by the half-life time to get the age of a fossil. So we can take this age of a rock and be able to tell how old a fossil that is trapped in the rock is, which can tell us a lot about life and how life has changed on Earth. All right, if we go over to 2 half-lives and then go up, that fraction is 1/4. If 2 half-lives have passed, then 1/4 of the original parent material remains. And 3/4 is dark. If the half-life time of an isotope is 10,000 years, meaning it takes 10,000 years for half of that sample to decay, and 3 half-lives have passed, what's the age of the fossil? In this case, you would just multiply those numbers. So you would have 10,000 times 3, which would mean 30,000. The fossil would be 30,000 years old. So radiometric dating is possible because each radioactive isotope decays at a constant rate. So we know how long it takes certain radioactive isotopes to decay. And so if that radioactive isotope is in a rock and we have a fossil in that rock, we are able to tell how old that fossil is because of that decaying constant rate. You cannot use this method for sedimentary rocks because they are formed from so many different pieces of other rocks. And so there'd be so many different ages of rocks, and you wouldn't know which one it was. So that's why for sedimentary rocks, we use relative dating, being able to tell first, second, last, which is oldest, which is youngest, but age. Another kind of absolute dating is tree ring dating. Tree rings are a glimpse into the past because we can use the width of the bands to look at how climate has changed over time and the number of rings also indicate age. So if you look in the very, very, very center of the tree ring, the very, very tiny dot in the middle is the first year of growth. If you look at the wide bands, so where there's a lot of space in between the bands, that means that it was a very rainy season. It grew a lot. If you look at the bands that are really, really scrunched together, it was a really dry season. It didn't rain a lot, and so it didn't grow a lot. And then you see that black charred mark. That means that there was a forest fire, and that tree has been scarred by the forest fire. To use tree ring dating, you must use a sample to be sure the results are accurate. So you must take samples from several different trees in an area to make sure that you get the same information about climate and age in one area. Another kind of absolute dating is ice core dating. So each layer of ice in a core corresponds to a single year or sometimes even a single season. And then almost everything that fell in the snow that year remains behind, including anything that was in the wind, so dust, ash, any kind of gases that were in the atmosphere, and even radioactivity can be trapped in ice. So if you look at this diagram, this is just a very simple diagram showing you different shades of gray and white, different colors that show you different layers to simulate seasonal layering. So ice core drilling happens with this cylinder drill that goes in really, really deep into ice and pulls out basically a tube of ice. And then inside that tube of ice are different layers. And inside each of those different layers are little gas bubbles. And inside of the gas bubbles are different amounts of dust and ash and all sorts of stuff from the air that was around whenever that ice formed. And so we know that if we're taking out a really long tube of ice, that the air was formed a long time ago. So we can tell about the climate from a long time ago by using